Hello guys, welcome to another session of Geometry and Trigonometry. In this session we will be looking at trigonometric ratios for special angles. Now in trigonometry there are angles that are usually referred to or are considered special because of certain reason that we'll talk about shortly. We will list these special angles and then we will try to find the trigonometric ratios, sine, cosine and tangent for these special angles. In addition to that, we will try to determine the trig ratios for angles that are related to the special angles. We call them the secondary special angles. These are angles that are outside the range 0 to 90, that is to say that they are obtuse or reflex angles. Okay? Let's be started. Now, the angles 0, 30, 45, 60 and 90 degrees are referred to as special trigonometric angles because it is possible to determine the trig ratios without the help of a calculator or a slide rule or even a logbook. Okay? Let's start with the angle 0 and 90, and this is simply because the angle 0 and 90 can be easily defined on the unit circle. What do I mean by this? So, of the 5 trig ratios, 0 and 90 can be defined on the unit circle. By definition, the sine of an angle theta is given by the height of a point P that is moving around the unit circle like so. So, the sine of the angle there, the sine is the height of that right angle triangle with point P moving along the circumference of the unit circle like that. Okay. Similarly, the cosine of the angle is the horizontal distance of P from the y-axis. So basically it's the distance OC. So the symbols C and S there are used intentionally to refer to sine and cosine. So whatever the height of P is above the x-axis or the vertical distance, it could be below it, the vertical distance will directly tell me what the sine is, and the horizontal distance will directly tell me what the cosine is, which is also to say that the coordinates of point P here could be expressed as C, S, because the x-coordinate refers to the cosine, the x-coordinate, and the y-coordinate refers to the sine, like that. Okay? Right, let's move on. And so, let's show how the point P can be made to move along the x-axis, along the circumference of the circle. We've done this before. So if I do that, point P now is parallel, or the length of the OP right now is on the x-axis, but I can make point P move, and you can see OP makes an angle theta with the positive x direction. So the sine, we can see that as P moves towards the top there, the value of S is increasing while the value of C is decreasing. That is, as P moves forward, the value of C, that length there, is decreasing while that length is increasing. If I move P back, we should be able to see that the value of S is decreasing while the value of C is increasing. So we can reason that when the angle is 0 degrees there, like that, when the angle theta is 0, the height of point P is 0. In other words, the value of sine of 0 is also 0. The value of the cosine of 0 must be 1 because C is now maximum there. Similarly, if I move point P up, you can see S is increasing while C is decreasing. So at 90 degrees, it is clear that S is 1. In other words, sine of 90 is 1, while cosine of 90 is 0. All right, so let's just write that down. So when P is on the x-axis, the angle is 0. So we can conclude that the sine of 0 must be 0 because now the height is 0. So sine of 0 has to be 0. Similarly, the cosine of 0 is the length C there, which is a maximum at 1. So we can conclude that the cosine of 0 is 1. All right? We move ahead. C, what about at 90 degrees? So when P is at the top there, or on the y-axis, then clearly we can see that sine is maximum while cosine is 0. So we conclude that sine of 90 is 1, while the cosine of 90, the length of c there, is 0. Okay? With that information, it should be possible for us to calculate the tangent of 0 and the tangent of 90 degrees. So, by definition, we know that the tangent of an angle is the sine of the angle divided by the cosine of the angle. This is, by the way, the first trigonometric identity. Okay? And therefore, the sine of 0 divided by the cosine of 0 would be 0 divided by 1. 0 divided by any number is 0. So we conclude that the tangent of 0 has to be 0. I hope I don't have to write that down. Similarly, the tangent of 90 must be sine of 90 divided by cosine of 90. Sine of 90 is 1. Cosine of 90 is 0. So the tangent of 90 must be 1 divided by 0. A number divided by 0 is always undefined or infinite. Okay? And so we write that the tangent of 90 is infinite. That's the symbol for infinity. Okay? So with that, we can conclude that now we know the trigonometric ratios, all the three trigonometric ratios for the angle 0 and 90 degrees. So we are done with 0 and 90. Now let's try and find the trig ratio for 45 degrees. Okay? The trigonometric ratio for the angle 45 can be found using a unit square. What is a unit square? Simply a square with a side of 1 unit. 1 millimeter, 1 centimeter, 1 meter, doesn't really matter, just a unit of 1. Here is an example of what I'm talking about. So that's a unit square if the length of the side is 1 and the height obviously is 1 because we are talking of a square. If I draw a diagonal there and I'm shading the side, one part of the square that we are going to make use of, because I'm cutting it right across the diagonal, the angle here, which is 90, will be split into 2, so it's that. And that means this is 45 degrees, right? And that is also 45 degrees. Okay? If we let this distance here be x, because if you're going to find the trig ratios, we need to know the sides, all the sides of the right angle triangle there. So if we make this be x, then we can reason using Pythagoras theorem. So by Pythagoras theorem, we can reason that x squared, so x squared must be equal to 1 squared, this one here squared, plus 1 squared, this one here squared, and this is actually 2 because 1 squared is 1 plus 1 is 2. So x squared is 2, and so to find x we must take the square root of both sides. So x is going to be the square root of 2, like that. Okay? So this we've already done. So x squared is 2, and so x is the square root of 2, and so we can replace that for x there. If we do that, now we have enough information for the right angle triangle to help us determine all the trigonometric ratios for 45. Okay? So thinking of 45 degrees, we can say, let's pick this 45 degrees. It doesn't matter, we could take that or this. We can get every information we need from one of them. So considering this as our angle of interest, the opposite is 1, the adjacent is 1, and the hypotenuse is square root of 2. So by SOHCAHTOA, the sine of 45 is the opposite over the hypotenuse. The opposite is 1, the hypotenuse is root 2, and so the sine of 45 is 1 over root 2. The cosine of 45 is adjacent over hypotenuse, so the cosine of 45 is also 1 over root 2. So we can conclude that the sine and the cosine of 45 are equal, and they are 1 over root 2. Okay? Now, 1 over root 2, sometimes when we have an irrational number in the denominator like that, sometimes it makes calculations, if we need to use this for further calculation, makes calculations a bit more difficult. So it's usually better to rationalize the denominator, and to do that, we need to multiply this, we need to multiply that by root 2, and also divide it by root 2. If we do that, then 1 times root 2 is root 2, but root 2 times root 2 is going to be 2. So 1 over root 2 can also be expressed as root 2 over 2 like that. And so the sine of 45 is root 2 over 2 or 1 over root 2. This means the same thing as that, but this is easier to use in subsequent calculation if needed. Okay? So sine 45 is the same as cosine of 45, which is the same as 1 over root 2, or if you like, the square root of 2 divided by 2. What about the tangent? Well, we can use sine and cosine like we did earlier to find the tangent, but it is easier to just look at the triangle and use SOHCAHTOA from the last part of SOHCAHTOA, that is TOA. The tangent of an angle is the opposite over the adjacent, and therefore, relative to this angle here, the opposite is 1 and the adjacent is 1, and therefore the tangent of 45 is 1 over 1 or just 1. So tan 45 is 1. All right? Physics students, this is sometimes very useful in kinematics and particularly in projectile motion. The fact that the tangent of 45 is 1 is going to be useful. It's also useful elsewhere, as you probably would already know. All right, so that is done. We are done with 45 degrees. Let's look at the remaining one, which are 30 and 60 degrees. Now, to find the trig ratios for the angles 30 and 60 degrees, we need to start with an equilateral triangle of side length 2, like that. What I'm going to do now is to draw a perpendicular, okay, to cross the base in the middle. If I do that, and then shade as a side that I want to work with, so this is going to be 1 because the whole thing is 2, so it splits the base into 1 and 1. All right, because this is an equilateral triangle, the angles, okay, the angles are 60 degrees, and because the top is being split into 2, that makes this 30 degrees. Okay, so we have 60 degrees and 30 degrees just as we wish to have. Okay, and because that is now let the height there be h, and let's work to calculate that value of h. All right, using Pythagoras theorem one more time, we will find that the hypotenuse squared, that is 2 squared, must be equal to the adjacent squared, 1 squared, plus the height there squared, h squared. The height is the opposite to 60 degrees, like that. And so that is 4 equals 1 plus h squared. Take 1 to the other side. We get 3 is h squared, which is to say that h, this tells us that h is the square root of 3. So we know that that vertical height there must be the square root of 3. Let me just erase this so that we type it nicely. Okay, so 2 squared is 1 squared plus h squared. Hypotenuse squared is that squared plus that squared. And if we rearrange, we will get that h is the square root of 3, as we have already shown. So now I can replace that h there by root 3. And now I have all the sides that I need to have in order to find the sine, cosine, and tangent for the angle 30 and 60 degrees. So let's start with 30 degrees. Maybe let's start with sine, and we look for the sine of 30 and the cosine and the sine of 60. Okay, so for 30 degrees, the sine of an angle using SOHCAHTOA is the opposite to 30 degrees, which is 1. Opposite over hypotenuse, the hypotenuse is 2. So sine of 30 degrees is opposite 1 divided by 2. Sine 30 is a half by definition. Okay. Similarly, sine of 60, now we are talking of the angle 60, the side opposite to 60 is root 3, and that is still the hypotenuse. So sine of 60 is root 3 divided by 2. And if we do that, we get sine of 60 there as root 3 divided by 2. Similarly, the cosine of 30 degrees, the cosine of 30 is the adjacent over hypotenuse. So adjacent to 30 is root 3 divided by the hypotenuse, which is 2. So the cosine of 30 is square root of 3 divided by 2. And similarly, you can see that the sine of cosine of 60 degrees, cosine of 60 degrees is going to be adjacent over hypotenuse, which is a half, like that. And with that information, it now becomes very easy to find the tangent if you wanted to use this information. Alternatively, just look at the right angle triangle and we should be able to find tangent of 30 directly there, as well as tan of 60. Tangent of 30, tangent of an angle is opposite over adjacent. So tan of 30 is the opposite to 30 over the adjacent to 30. That is 1 over root 3. So tan of 30 is 1 over root 3, which we can also, again, if we wanted to get rid of that irrational number in the denominator, then we can again multiply and divide. We can multiply by root 3 and divide by root 3. Hope that is visible. And that gives us root 3 over 3. So the tangent of 30 can be expressed as 1 over root 3, or we can express it as root 3 over 3. This is better, again, because we have rationalized the denominator. It is easier to work that in subsequent calculations. Right, that is tangent of 30. What about the tangent of 60 degrees? Well, the tangent of 60 degrees is the opposite to 60 over the adjacent to 60. So that is root 3 over 1, which is just the square root of 3. So tangent of 60 then is simply the square root of 3. Okay? That concludes 30 as well as 60 degrees. So without the help of a calculator or any point of reference, we can use our knowledge of geometry directly, just a square and a square of side 1 and an equilateral triangle of side 2 to help us find all the trigonometric ratios, of course together with the definitions of the unit circle for 0 and 90 degrees. Okay, I believe I have a summary table for this. I've included a second row there where the angles have been expressed in radians. If you do not know how to change angles from degrees to radians, please watch the video. I think it's the previous video where we have talked about the radian measure. Okay, and so this is a summary of the results. There are simple ways. I think I learned this from my student. There are simple ways of memorizing this in case you need to do so, especially in Paper 1 in the IB Diploma program. Paper 1 AA, HL or SL, you do not have a calculator with you, so you would normally need to know these offhand. You do not need to memorize them. You've already seen a very simple way of determining them. Okay? We will stop this video here, and when we get back, we will try to look at the trigonometric ratios for related special angles. So that is angles that are related to these 5 special angles. We'll try to find the trig ratios of such angles. An example would be 120 is related to 60 and 30. 135 is related, an angle of 135 is related to 45 degrees, and so on. 270 and 180 are related to 90 degrees. So we will see how to determine the trigonometric ratios for angles that are greater than 90 degrees. Okay, so see you shortly in the next video.